Welcome. This video is intended for elementary educators who are studying sequences as part of their look at elementary mathematics. This is SUNY Genesio's Math 141, and so I'm going to assume that all of us have seen some sequences from our work in Math 140, but if not, you have seen this in previous coursework, like from high school. So you'll remember that there are some sequences that are arithmetic, and arithmetic sequences are things like 10, 13, 16, 19, and so on. In an arithmetic sequence, there is a common difference. And by common difference, we mean that we add 3 to get from any term to the next term. Any term can turn into the next term by simply adding the common difference. And so, in general, your textbook says that the first term in an arithmetic sequence is usually called a sub 1. And then to get to the next term, you would take that a sub 1 and add some common difference. And then to get to the next term, you would take that term and add the common difference again, and so on. A sub 1 is the first term. D is the common difference. D for difference. We usually try to have our variables be meaningful. So someone might ask, what's the nth term? Well, that's fair to ask about the nth term. So we recognize that if n is 1, it looks like this, and if n is 2, it looks like this, and if n is 3, it looks like this, and if n is 4, it looks like this. Well, the n equals 4, there's a 3D, and with n equals 3, there's a 2D, and with n equals 2, there's a 1D, so you might think that a sub n is a sub 1 plus n minus 1 d's, and you'd be right. Now, this is a seriously intense sentence. This says an awful lot. This says if I want a generic term of the sequence, the nth term, start with the first term and add on n minus 1 copies of the common difference, which sort of makes sense. To get to the fourth term, there's 1, 2, 3 gaps of d. To get to the third term, there's 1, 2 gaps of d. So it makes sense that to get to the nth term, there are n minus 1 gaps of d. And so someone might ask, let's pretend there's an arithmetic sequence, and we know something about the arithmetic sequence. We know that the second term is 7, and we know that the fifth term is 22. And I want to know what's the 50th term. Now, I'm not the most let's do it the hardest way kind of a person. If I were, I would say, well, we'll just figure out what some of the terms are and we'll just extend the pattern and we'll write out 50 numbers and we'll get a sub 50. That's legit, but that is not recommended. Why? Because it takes too long and it doesn't show the structure of what's going on. So instead, let's consider that there are 3 Ds, and those 3 Ds have to pick up a gap of 15. 3 Ds have to pick up a gap of 15. So D is 5? And if D is 5, then the 50th term is the first term plus n minus 1 d. So as long as we know what the first term is, we know what the 50th term is. Well, the first term comes from adding 5 to something and getting 7. So that something is 2. So the 50th term is the first term plus 49 times 5. and we know exactly what that 50th term is without having to figure out all the ones in between. And so that is a valuable skill for us to pick up, and it takes advantage of the structure of an arithmetic sequence. We also took a look in Math 140 at geometric sequences. Geometric sequences are things like 3, 12, 48, 192, dot, 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 where there is a common ratio between terms. And that common ratio, we're going to multiply by 4, multiply by 4, multiply by 4. The common ratio is 4. We studied these sequences in Math 140, so I'm just refreshing our memory on that here. What happens with a geometric sequence? There is some first term, and then we multiply that by r, and then we multiply that by r again, and then we multiply that by r again, and so on. So we might well ask, what's the nth term of a geometric sequence? Well, the nth term appears to be the first term times r to some power. Well, what power? This is the n equals 2 case, this is the n equals 3 case, this is the n equals 4 case, and so it appears, as before, that there's n minus 1 copies of r, and that seems right. This is the nth term of a geometric sequence. So it bears asking, if you have a geometric sequence, what is the 20th term? Well, the 20th term is the first term times r to the 20 minus 1. Well, we got to know what r is. Times r, times r, times r. 1, 2, 3 copies of r. When we take 5 and multiply by r by r by r, we get 40. So r cubed is 8. And that means that r is 2. Well, that means that a sub 20 is the first term times 2 to the 19th. Well, we know what the first term is. The first term is 5 times 2 to the 19th. Now, that's a huge number. That happens to be the number 2,621,440, but that's not nearly as important as seeing the structure, because then the calculator does all the work for you. And we can find the 20th term without having to find all the terms in between. I'll say one other thing about sequences. Some sequences are Fibonacci sequences. Fibonacci sequences are rather interesting to study. They usually start 1 and 1, and then in a Fibonacci sequence, each term after the second is the sum of the two before it, 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 and so on. This sequence is much beloved by mathematicians, and it is well studied. So this is worth a look on Google or Bing or whatever is popular when you happen to get this video in your queue. That's worth studying. So just so you know, there are other ways to make sequences than arithmetic or geometric, and this doesn't even scratch the surface. But I hope that this is helpful to you as you're studying, and I wish you well as you prepare for class.